Now, at a high level, Helm is just a package manager that allows you to deploy its packages that it refers to as Helm charts into a Kubernetes cluster. And what I want to show you today is how we can take one of your existing applications and package that application's infrastructure into one of these Helm charts. That way, the infrastructure of your application can be stored either in your code or in a separate Git repository and easily deployed to a cloud environment by you or someone else. Now, before we start this, there's a couple things that you're going to need. The first thing that you're going to need is the Helm binary. So you'll have to have an install of Helm. The two ways that we can do this are we can either install it directly from the Helm website at helm.sh. If you go there and scroll down a little ways, there is a bunch of different ways that you can install it. Or if you're using OpenShift, which this video is going to heavily rely on a couple different OpenShift pieces, you can install it directly from the OpenShift by going into OpenShift and clicking the question mark button at the top right-hand corner, and then under that, command line tools. And there you'll see the Helm 3 CLI and download Helm. And so you can download this one directly from OpenShift. Both instances of Helm should work just fine. The one that comes with OpenShift has a couple minor tweaks and a couple little things that help it integrate with OpenShift a little bit better, but either one should work. So once we have our Helm binary and we've got our Kubernetes cluster, we're ready to make our Helm chart. Now, creating your initial Helm chart is pretty simple. It's just a single command built into Helm called Helm create. And then you just want to give the name of whatever you want your chart to be named. So we'll call ours example. And that will create this example file or folder. If we take a look at what's in that folder, let's just go from top to bottom here. So we've got charts. You don't have to worry too much about that in this particular demo, but the charts folder is just going to be holding any dependent charts that your chart has. So if you're dependent on another Helm chart, it'll be stored in here. The next thing is this chart.yaml. So this chart.yaml is going to actually describe your Helm chart. So let's take a quick look at that. So we've got your API version here. For Helm 3, your version is always going to be v2 for the most part. Name and description should tell us what your Helm chart does. So I'll even change my description here to just an example Helm chart. Your type is generally going to be application. You can look up a little bit more. It's either going to be application or library. Library charts are charts that have specific functions that can be used by other charts. Most of the time, you're going to be sticking with application. And then your version here will give version information about your chart. This is how other charts will refer to your chart. If they're using your chart as dependency, they'll refer to this version. This version information will also show up, as we'll see later on the OpenShift UI. So it's a way to easily tell what chart is currently being deployed out there. So it's pretty important that every time you make a release of a specific chart that this version gets updated, so you know that information. And then app version is a little bit more loose. Whatever you want to define as an application, whether it be a set of charts or anything else, you can put that in this app version. And you notice this top version, it asks to follow semantic versioning. You don't have to do that with the app version. That can be whatever you want. This may also contain information like dependencies to other charts underneath, but we're not going to talk too much about that in this video. The next thing underneath charts is this templates folder. This template folder is going to have all the templating information for your Helm chart. So the first thing that I want to look at under this template folder are all these YAML files. So deployment, HPA, ingress, service account, and service. Now, if you've ever done any Helm or any Kubernetes work before, some of these names might look familiar, like deployments or horizontal pod, scalers, or ingress controller, service accounts, and services. These different YAML files are all just representations of different Kubernetes resources. Real quick, there is no specific thing that you have to name or any specific naming convention that you have to use when you're doing Helm. But I do really like the way that they do it here, where they just use the name of whatever the Kubernetes resource is as the name of the file. And if you have multiple of them, like if you have multiple secrets, I personally like breaking each secret up into its own secret file and just doing secret dash and then a description of what that secret is for. Some folks will like to take all the secrets and put them into a single file. I think that actually is probably the more popular way. That's the way I see it more often. But you can go either way. You can have multiple Kubernetes resources in a single YAML or break them out. And in fact, let's take a quick look at one of these guys. So we'll just look at the service. Service is fairly simple normally. So inside of here, you can see it looks pretty much like you would expect a Kubernetes resource to look, other than these pieces that have the devil squigglies. We'll talk about this a little bit more in detail later, but anything inside of these devil squigglies are going to be templatized. And there are functions. So if you look at this include, that's a function. And then there are values that you can use. So try to remember this .values, .service, .type, and this .values, .service, .port. These are both different values that can be passed into the chart and templatized. And we'll look at how that works in just a little bit. The next couple things that I want to point out are things that we're not necessarily going to go over too deeply in this particular video, but I do want to mention them. So you see this .tpl function or file. We'll take a really quick look into that. So this is a template file. If you have really complicated values that maybe are created from multiple variables that you want to templatize, or variables that may or may not be in there, you can kind of simplify it with this template helper. My recommendation is the first couple times that you make a Helm chart, or the first go that you have a Helm chart, not to worry about trying to create this TPL. It can be very useful as your chart gets more complicated, but you don't need to use it at all. Everything that you do inside this template file can be done directly inside of the YAML files. The notes.txt is just information that you can give your developers or give whoever is using your chart. So if we look real quick in there, it's just kind of a little blurb, and you can have templated values inside of the blurb, but it's just a little blurb that talks about what the chart does, how to use it, that sort of thing. And this is something that they'll see whenever they deploy the chart into their environment. And then the last piece here is these tests. We're not going to create any tests in this particular one, but all this test folder is it's a set of a Kubernetes resources, usually pods that are used to kind of test and make sure all of your other to make sure your chart or your current release actually works. So it's a way for a person using your chart to validate that all the different connection and integration points work. And that usually just creates basically, like I said, a pod that'll start up and actually try to, run your application, quote unquote. And then the last thing in here is this values.yaml file. So if we take a look at that, you can see it's got a bunch of different values, and these are all the values. These are all the default values that can be templatized inside of your Helm chart. So we remember that service that we saw before. We saw .values, which says to take something from this values file, .service, .type, and .cluster. So you can see that's just going to be pulling from this portion right here, this service with type, cluster IP, and port 80 by default, but that can be overwritten. All right, now that we've had a chance to look through the default chart that Helm created for us, the next thing that I want to do is basically delete everything in it. So we're going to go into our templates directory here. We're going to remove everything. And then we're going to go into our values.yaml, and we're also just going to remove everything in here as well. And the reason that I want to do this is while I think that the chart that gets automatically created by Helm is a really solid chart for starting on a new application deployment, once you're a little bit more familiar with how Helm works, It can be a little overwhelming at first. There's kind of a lot going on. So for this video, we're going to go really, really basic. And to start off with, we're just going to create a Helm chart with a single deployment that spins up 3 pods as our initial Helm chart. And then we're going to build from there. So in order to do that, we're going to Alt-Tab into our OpenShift environment. And the way I'm going to do this, I'm going to go into search here and I'm going to look up deployment, and feel free to use deployment config if you're more comfortable with that. I'm just going to use a deployment. We're going to click create. Now here we're going to delete the namespace because we want, when we do the Helm deployment, for it to deploy to whatever namespace that we're currently pointed to in our Kubernetes auth of. But everything else here is fine and remains the same. We're just going to copy this whole hog and then paste it into templates / deployments.yaml or deployment.yaml. And at this point, we have a totally valid Helm chart. We can deploy this on our Kubernetes environment and it should work just fine. And in fact, let's go ahead and do that. So we'll just do a Helm install, and the Helm install command takes a release name. So we'll call our release deploy or demo-release. And then it takes the location of a Helm chart. And that location can either be a file location on your local system, or it can be a location that points to a repository somewhere. Or if you have repositories set up, it can just be the name of the Helm chart that you want to deploy. In our case, we're going to point to the file location, which is our current directory. So we'll just put a dot. And you can see that we were able to successfully install our chart. If we do a Helm list, it lists all the current releases in the project or namespace that we're currently pointed at. And so we can see a little bit of information about our chart. Now let's go back over to the OpenShift environment. And I'm going to be using the developer tab for most of my demonstrations here. So if we look at topology, we can see that we've got a Helm release, which is this square box in the background. We can actually click on that and get some information about the release. And then we can look at the deployment itself. So we've got our deployment and it's spun up its 3 pods. We can also look at information about the Helm release based on this little Helm tab here. And it gives us, at a first glance, similar information to the Helm list command, but we can click this and get more detailed information, including revision history. So as we do more releases, we can see what the history of the chart deployments looked like. And then release notes. And these release notes will be that notes.txt that we talked about beforehand. That would appear here if we had added one to our chart, which we may do later. And then finally, this resources. This resources tab is actually extremely useful. Right now, we've only got a single deployment associated with our Helm release, so not super useful here. But as you get 10, 20, potentially more Kubernetes objects associated with your Helm release, this can be really useful for being able to find those objects and understand a chart if you're using someone else's chart. So we were able to do a basic deployment of a Helm chart, so great job. But you're probably thinking like, okay, well, I could have just done an OC apply against this YAML file and ended up with the same thing. So now that we were able to do a basic deployment, let's go ahead and add some templating to our chart. So the first thing that we're going to do is we're going to go into our templates / deployment.yaml. Let's go ahead and template the replicas value. So this is the number of pods our deployment spins up. So to do this, we're going to do the open squiggly, close squiggly, and that's double squiggly brackets. And then we're going to do dot values. Dot values is what's called a built-in object, and we'll look at some other built-in objects, but this is the most common. And this is going to give you access to everything in that values.yaml file. Just a quick note, you may also see $values. This is actually a slightly safer way to do it. But for right now, the $sign or no $sign, these are both functionally equivalent. So we'll do .values, .deployment, .replica. And this will be our number of replicas. So what this is going to do now is it's going to look inside of our values.yaml file for something called deployment. And under deployment, it's going to look for a variable or a key called replica. And so why don't we default ours to 2 instead of 3 for now? And we'll just do, and we'll just redeploy our Helm chart. So this time, instead of using the Helm install, we're going to use the Helm upgrade. It works the same way as the install, only it upgrades to a newer version of an existing Helm chart. And in fact, what we're going to do is do Helm upgrade and then space -i. And what the -i does is it says that if the chart doesn't exist, then do an install. I prefer to just do the Helm upgrade -i when I'm doing it not as part of an automated pipeline, just because it's a single command I have to remember instead of having to remember both upgrade and install. And then everything else will be the exact same. So it's called demo release and then dot. And then we can see now we're on revision 2. And what we should have, if we tab over to our deployments, is you can see that it's terminating one of our pods. So our deployment now has 2 replicas. So great. And I've said a couple times during this video, but everything inside of your values.yaml file is your default values. So they're all designed to be overwritten. So let's override our default value of 2 just inline for now. So we'll do the same command we just did, upgrade -i, demo release dot, and then we'll just do -- set, and then it's just key and value. So our key here is going to be deployment dot replica, and then we're going to, let's say, make that equal 4. So now we're going to have 4 replicas. And we're on our 3rd revision. And if we look back here, we should be spinning up 2 more replicas. So now we have 4 pods. So fairly simple. Now, overwriting values through the CLI is really useful for being able to quickly do a deployment and some testing out with Helm charts. But most of the time in real environments, you're probably going to want to store all of those values that you want to override into a file. And then you're going to want to deploy that or do a Helm install that uses that file to override your values, especially when you start talking about things like automation. So for our demo purposes here, let's create 2 new fake environments. So we're going to create a dev environment and a prod environment and do 2 new Helm releases onto our example namespace. So the first thing that we want to do is let's go ahead and uninstall our current Helm install. So we're just going to do Helm uninstall and then the name of our release, which is demo, or for me at least, it's demo release. And now we're going to create 2 new files that hold our development and our production environment overrides for our Helm chart. So to do that, we're going to copy our current values.yaml into 2 new files, one values-dev.yaml, and then values-prod.yaml. And in our values-dev.yaml, we're going to change our number of replicas to 1. So we're just going to have a single replica for our development environment. And then our production environment will have, let's say, 6 replicas. We really don't want that environment going down, so we'll knock it up to 6. And so now we're all set to be able to deploy our 2 new environments. So let's go ahead and try that and see what happens. So to do that, we're going to do Helm upgrade -I. And for our development environment, we'll just call it dev release. And we'll do the dot. And in order to specify our new development.yaml file as the file that we want to use to override our default values, we're just going to do -F and then specify the file location. And a lot of folks, especially when your Helm chart is part of your code, will put these values-dev.yaml directly in their chart, but it doesn't have to be. It can be anywhere on your system, or it can even be on the internet if you'd like it to be. So you can put a URL to a Git repository file somewhere out there. But we will do values-dev.yaml here for our dev release. And then we're going to do the same thing for our production release, except we'll call it prod release, and we will be specifying the prod.yaml file. So you can see here that we are getting an error, and the error has to do with the fact that we have a deployment named example already on our namespace. That's because our deployment name of example was already deployed with our dev release. So what we need to do here in order to make this work for our demo is we need to make the deployment name dynamic. And so the way we can do that is we can go inside of our templates and our deployment.yaml, and we can change this name here to be a templated value. So we can do .values.name, let's say. And what that means is we could, in theory, come in here and inside of our, our values.prod or -prod, we could add a new variable up at the top here called name and call it prod or whatever we want it to. But rather than doing that, let's use a function called default. So let's go back here, and we're going to use a function called default. And in order to do that, we're going to do pipe and then default. And what this will do is it'll pipe whatever this value is into this function. Now, let's take a quick look at what default actually is. So if we come to our Helm documentation here, and we go up here to the top and click docs, firstly, this documentation is really great. It's got a ton of tutorials. After looking at this video, would recommend spending some time here. But to find the specific thing we're looking for, we're going to go into this chart templating guide, and we're going to look at this list of template functions and pipelines. Or actually, sorry, this template function list. And this has a list of a ton of different functions, and they do a pretty good job of breaking them out by category on what they do. So the function that we're going to look for is just going to be default. So that's apparently under the logical flow and control functions. We'll click here, and you can see basic description of what it does, and it does what you may imagine it would. It will take a specific value, in this case .bar, and if that value does not exist, it'll default it to another value, in this case 2. So here we could default this into some hard-coded value, but that really wouldn't solve our problem. So we're actually going to look at one more concept here of the built-in objects, the things that I described before when I mentioned values. So we're going to come back here, and we're going to look at built-in objects. And under here, you can see a bunch of built-in objects that come and you have access to when you do a Helm release. And you can see that values is here, and values is, as I said, the values passed in either from the values.yaml file or supplied to you by the user, either through the CLI or the other values files that they specify. In this case, we're going to look at a different release object or a different built-in object, and that built-in object is the release, which gives us information about the release. You can get the name, the current namespace it's in, whether or not it's an upgrade or an install, the current revision number. The one that we care about here is the name. So what I want to do is, if the user doesn't supply us a name, I want us to default the name of our deployment to the release name. So we'll just do this, release.name. And so in that case, we should be able to do an upgrade of our development chart. So our dev release will do an upgrade, the exact same command that we put in before. Minor typo here. The name here should be capitalized. But we'll do an upgrade of that release that we had before, and we can see now we're on revision 2 of the release. And if we look back at our topology chart, you can see our deployment is now named dev release and not example as it was before. And what this means is we now should be able to do